As we saw in the last lecture, a major cause of climate change is rapid rise in the level of carbon dioxide in the atmosphere over the last century. If we could reduce the amount of CO2, perhaps the rate of climate change could also be slowed down. One potential method involves enhancing the role of the soil that plants grow in. With regard to absorbing CO2, Pratala, a soil scientist from Ohio State University in the USA, claims that the world's agricultural soils could potentially absorb 13% of the carbon dioxide in the atmosphere, the equivalent of the amount released in the last 30 years, and research is going on into how this might be achieved. Let's first get to the idea that soil might be available in this way not through an interest in climate change, but rather our concern for the land itself and the people dependent on it. Carbon-rich soil is rank, crumbly and fertile and retains some water, but erosion can occur if soil is dry, which is a likely effect if it contains inadequate amounts of carbon. Erosion is a bad for people trying to grow crops incorporate any more of the terrain. In the 1970s and 80s, Love was studying soils in Africa so devoid of organic matter that the ground had become extremely hard to plant cement. Then he made a pioneer in the study of global warming, who suggested that carbon from the soil had moved into the atmosphere. This is now looking increasingly likely. Let's meet again. For millions of years, carbon dioxide levels in the atmosphere have been regulated in part by a natural partnership between plants and microbes and tiny organisms in the soil. Plants absorb CO2 from the air and transform into sugar and other carbon-based substances, where a proportion of these carbon products remain in the plant. Some transfer from the roots to fungi and soil microbes, which store the carbon in the soil. The invention of agriculture some 10,000 years ago disrupted these ancient soil building processes and netted lots of carbon from soil. When humans started draining the natural topsoil and allowing it up for planting, they exposed the parent carbon to oxygen. This created carbon dioxide and released into the air. And in some places, grazing by domesticated animals how removed or vegetation releasing carbon into the air. Tons of carbon have been stripped from the rural soils where it's needed and pumped into the atmosphere. So what can be done? Researchers are now coming up with evidence that even modest changes to farming can significantly help to reduce the amount of carbon in the atmosphere. Some growers have already substituted an approach known as regenerative agriculture. This aims to boost the fertility of soil and keep it moist through established processes. This includes keeping fields planted all year round, and increasingly the variety of plants are being grown. Strategies like this can significantly increase the amount of carbon stored in the soil. So agricultural researchers are now building a case for their use in combating climate change. One American investigation into the potential for storing CO2 on agricultural lands is taking place in California. Soil scientist Wendy Silver of the University of California, Berkeley, is conducting a first-of-its-kind study on a large cattle farm in the state. She and her students are testing the effects on carbon storage of the compost is created from waste, both agricultural including manure and contacts, and waste produced in gardens such as leaves, branches, and lawn trimmings. In Australia, soil ecologist Christine Jones is testing another promising soil enrichment strategy. Just 12 farmers are working to build up soil carbon by cultivating grasses that stay green all year round. Like compounding, the approach has already been approved experimentally just now hopes to show that it can be applied on working farms and that the resulting carbon capture can be accurately measured. It's hope in the future that projects such as this will demonstrate the role that farmers and other land managers can play in reducing the harmful effects of greenhouse gases. For example, in countries like the United States, where most farming operations use large applications of fertilizer, changing such land-standing habits will require a change of system. Furthermore, I guess that farmers should receive payment not just for the corn and beef they produce, but also for the carbon they can store in their soil.